Today I'm going to discuss the Cramers Rule. Cramers Rule is a method used in solving a system of linear equation or root finding. So before we go to a Cramers Rule, we have our reminders. So we need to test the system if it is possible to use the Cramers Rule. So first, the matrix should be a square matrix, and the determinant of a matrix should not be equal to 0. So I have here an example. The first step in getting the Cramers Rule is to transpose this equation to an augmented matrix. So let's transpose it as an augmented matrix. So our given equation is x plus 2z is equals to 9, 2y plus z is equals to 8, and 4x minus 3y is equals to negative. So we have 1, 0, 2, 2, 1, and let's transpose, or let's have transpose it or substitute as an augmented matrix. So we have 1, 0, 2, 0, 2, 1, and 4, negative 3, and 0. Then, also the coefficient here, let's substitute it here, negative 2. But first, the first step is getting the determinants of this matrix. This is not included. So, in finding the determinant of these, let's have 1 times, let's eliminate this layer and the numbers that left is the equivalent. Let's put it right here. So 2, 1, negative 3, 0 minus, and if we eliminate this portion and the numbers that left is the equivalent. Let's substitute it here for the 0. So minus 0, 1, 4, 0 plus, again, let's eliminate this column and this row, and the remaining numbers, let's substitute it down here. So 2 times 0, 2, 4, and negative 3. So let's multiply these two numbers. So 2 times 0 is equals to 0 minus negative 3 times 1 is equals to positive 3, since we have a minus sign here, so positive 3 minus 0 times 0 is 0 minus 4 times 1 is equals to negative 4 plus 0 times negative 3 is 0 minus 4 times 2 is equals to negative 8. So let's substitute. So 0 plus 3 is equals to 3 times 1 is equals to 3 minus, since times 0, so 0 na to. So negative 8, 0 minus 8 is equals to negative 8 times 2 is equals to negative 16. So 3 minus 16 is equals to negative 13. So our determinant for this matrix is equals to negative 13. But if we need to find the value for each variable. So let's call it the d of x, d of y, and d of z. So in order to find the value of d of x, d of y, and d of z, the coefficient, we will substitute this coefficient column. We substitute this column to this column for the d sub x. And if we find the d sub y, let's substitute this coefficient to the column for the d sub y. And lastly, for the d sub z, let's substitute it for the column for this d sub c. So I'm gonna put the equivalent determinant that we found earlier. So our determinant is equals to negative 13. So let's find the d sub x. So as I told you earlier that we have to transpose or substitute the value of coefficient to this column for the d sub x. So the matrix will become 9, 8, negative 2, then 0, 2, negative 3, 2, 1, and 0. So, like what we did in the first part, we eliminate this portion for us to find and put it in times 9. So, eliminate this portion, then the values left is 2, 1, negative 3, 0, minus 0 times eliminate this portion, then equivalent, the numbers left are 8, 1, negative 2, 0, plus 2 times 8, 2, negative 3, negative 2, sorry, negative 2, and negative 3. So again, we perform raw operation. So 2 times 0 is equals to 0 minus negative 3 minus negative 3 times 1. So this is positive 3 minus 8 times 0 is 0. Negative 2 times negative 2 times 1 is negative 2. Since we have negative minus sign here, it will become positive 2 plus 2. 8 times negative 3 is equals to negative 24 minus negative 2 minus times 2 is equals to negative 4. Since we have negative here, it will become positive. So plus positive 4. So 0 plus 3 is equals to 3 times 9 is equals to 27. Since this is 0, so negative 24 plus 4 is equivalent to negative 20 times 2 is equals to negative 40. So 27 minus 40 is equals to negative 30. So our d sub x is equivalent to negative 30. So let's put it right here. And so let's find the d sub y first. So for the d sub y, as I told you earlier again, that we have to transpose or substitute the value of coefficient to this column for the d sub y. So let's substitute it. So it's equal to 1, 0, 4 and 9, 8, negative 2, 2, 1, 0. Again, as I told you earlier in our process, we have to eliminate this term and let's put it as the matrix for this one. So 1 times 8, 1, negative 2, 0, minus 9, 0, 1, 4, 0, then plus 2 times 0, 8, 4, and negative 2. Equals to 8 times 0 is 0, minus negative 2, plus times 1 is equals to positive 2. 1 times positive 2. Then 9, 0 times 0 is 0, minus 4 times 1 is equals to negative 4. Plus 0 times negative 2 is equals to 0, minus 4 times 8 is equals to 32. So 2 times times negative 32. So 1 times 2 is equals to 2 minus 9 times 4 is equivalent to 96. So 36, positive 36. Minus 32 times 2 is equivalent to 64. So minus 64. So 2 plus 36. 2 plus 36 minus 64 is equivalent to negative 26. So our d sub y is equivalent to negative 26. So let's substitute it here. So d sub y is equivalent to negative 26. So the last is to find the d sub z. So let's substitute the coefficient value to the volume of the d sub z. So d sub z is equals to 1, 0, 4, 0, 2, negative 3, then 9, 8, negative 2. Then again, as we all know, 1 times 2, 8, negative 3, negative 2. Then minus 0, then the matrix 0, 8, 4, negative 2, plus 9, 9, then 0, 2, 4, negative 3. So let's compute. 2 times 2 is equals to negative 4. Minus 8 times negative 3 is negative 24. Minus 0 times negative 2 is negative 2 minus 32. So I have an error. So 0 times negative 2 is 0. Then 0 times negative 3 is 0. 0 minus 4 times 2 is equals to 8. So let's compute. So negative 4, since it is negative, it will become positive. So 24 minus negative 4 is equals to 20. Since it is equals to 0, then 0 minus 8 is negative 8. Then negative 8 times 9 is 72. Minus 72. So 72 minus 20 is equivalent to negative 52. So the value of our d sub y is equals to negative 52. But our answer is not this. We need to divide it to the determinant that are computed. So let's divide it. Negative 13 is equals to 1. Then divided by negative 13 is equals to positive 2. Then divided by negative 13 it will become 4. So our determinants or the roots